So, everyone, welcome back to our drone enhanced spectrum measurements panel, or actually presentation with Tom Brinkoetter, who is the founder of RadioSiteTest.com. Some of you might remember Tom from the last few NSMAs. He steadily brings in a lot of new data on drones and spectrum management, and we're always mesmerized by it and appreciate him coming in. A little background on Tom. He's a wireless test expert with extensive hands-on experience running all types of electronic test equipment. He believes that drone-based measurements can help wireless site managers significantly improve the performance of their systems. Tom's extensive knowledge in the field of RF test and measurements comes from over 40 years of experience at HP, Tektronix, and Ritsu. He's the author of Interference Hunting with the Anritsu Fieldmaster Pro MS2090A and is a trainer for Anritsu and Motorola on the S412E LMR Master. He has a Bachelor's of Science of Electrical Engineering from the University of Illinois and a Master's from Stanford University. And welcome, Tom, and take it away.
Thanks, Joe, and thanks for inviting me to speak again. So I'm going to update the work I've done in the past year on doing wireless measurements with drones. And you see in the picture there a recent activity. It's a 118 to 136 antenna for hunting interference in the air band. The drone is a Whisper Ranger made in the U.S. in Mississippi. And we'll talk more about that kind of activity. So I see when I first started doing this drone stuff, of course, I was a spectrum analyzer guy way before that. And there's a big opportunity to get these things up in the air to make measurements. And I think the two big applications are interference hunting and antenna pattern verification. And I'll add to the interference being more than just unwanted. There's people with two-way radios in the distance that I've had customers want to hunt for. There are wildlife collars that fit in the same. So the same measurement set on a drone would fit into this interference hunting scenario. But why would you go about doing that? Of course, height above average terrain. The math is pretty simple. It's tangent math to the tangent to the Earth. It gets more complicated if you start to include the subtleties, diffraction, reflection, Fresnel, all that. But in general, it's proportional to the square root of the height. And to give you an example, a two-way radio, 1 watt portable radio, 150 megahertz, you might go 3 to 5 miles. If you take that radio up to 400 feet, you increase its ability to hear to 20 to 40 miles. So that's a significant increase. And that's a big advantage for wildlife hunting and, of course, for interference hunting as well, to be able to get a good direction to the signal that far away. And the other big issue in the last year, I've done a lot of interference hunting on the ground for the carriers. And I can tell you that the metal objects from cars and buildings is just a nightmare. It makes it very difficult for you to put video on. Okay, let's see if I can turn the video on. I'm not sure how to do that, Joe. Maybe you go over here. Let's do this and this. How's that?
There you are. So it's always good to connect a human with the slide.
Yeah, sorry, I should have been there earlier. So reflections are a nightmare. It just causes you to get wrong readings and drive the wrong direction. So getting up above that, as I'm doing this, you're always, when you're doing it on the ground, you always hope for a 3 or 4 story parking garage to get up at least 50 feet in the air to look over the top of all the metal. So multipath is a real barrier for interference hunting. Okay, so what do you need to do this? Well, you need a drone that can have a payload capable of flying a spectrum analyzer, and you certainly want to be sure the specifications on the drone support that. I've seen situations where people, you can put something on any drone, but if it doesn't have the specifications, then if you get into an issue with the FAA, you're in legal, or you're not doing good practice. You're going to need a good spectrum analyzer that can be portable and fly. You probably, as with any interference hunting, you're going to want filtering to be sure your measurements aren't distorted, or you're not chasing fictitious signals. And of course, you need a data link to the ground, which is a big one. You need to be able to see the results on the ground. So when you rotate the drone, you can look at the signal level and get a good vector to the interference. There are a number of so-called industrial drones out there. DJI from China was probably a leader for this kind of work 5 years ago. The Chinese drones are unpopular, and I think the American manufacturers are stepping up. The drone on the upper right is a Whisper Ranger. I have that. I have the one on the upper left as well, the DJI drone. So you need something with a 4 or 5, maybe the one on the upper left is 14-pound payload. So you need something with enough payload to carry the antenna that you plan to use, and the spectrum analyzer and the downlink to the ground. Another company in southern Washington State, Free Fly, used to be BFD, and they have 3 or 4 drones that are capable of this kind of work. Spectrum analyzers, that I've probably flown 10 to 15 different analyzers over the last 8 years I've been doing this. The easiest one to fly is the little Inritsu, that has capability to I believe it or not, 110 gigahertz. There are some limitations in the size, so you might want to move to something else. I've seen a big change with some of the manufacturers, and Ritsu for one, are willing to take the boards out of their portable analyzers and just fly that. They're built in a way that they'll stand alone. So I'm getting some requests to mount just the PC board to get the weight down, of course, to have a very high. The one in the upper right is a 54 gigahertz capable analyzer. So you have a very powerful, in real time, so you have a very powerful analyzer that you could fly. I think that without the case and everything is going to be under 3 or 4 pounds. So big opportunity for a really good spectrum analyzer up at 400 feet elevation. Antennas are a challenge, especially below 1 gigahertz. They get pretty big. The one on the left is the airband, 118 to 136. And I've managed to get the weight down to where my drone would fly it. There are some ultralight versions of the VHF, UHF in the middle. And then as you get to millimeter wave, 6 gigahertz, the horn there's a 6 gigahertz horn. Things get small enough that you can easily find antennas. Below 1 gigahertz, you have to do some work to get the weight down and get the wind load down. You don't want the wind to catch the antenna and cause the drone to have trouble flying. Recently, I'm doing VHF work. I've been requested to do work in the lower VHF range. And of course, noise is always a problem. As you go lower in frequency, all the LED sources and switching regulators generate noise. And of course, you're hunting for small signals, and you've got to keep that out of the system. I've heard some drone motors will jam VHF measurements. I heard that from a wildlife person that has drones for wildlife hunting. I'm seeing tremendous noise from the voltage regulators. I've got 3 or 4 regulators that I have to fly to make this whole system work. And you have to choose those regulators carefully. And then recently I've seen I'm flying a PC with downlink, and some of that equipment is really jamming GPS at 1.6 gigahertz. And that's a big problem. One, I need GPS to know where I am, for the measurement results. But the second, your drone is being controlled by GPS, and you really don't want to have any degradation of the drone operation from GPS jamming. So that's a real challenge when you're doing this kind of work. Here's an example kit. The drone is Whisper Ranger, as I said, out of Mississippi. It's got 7-pound payload, approximately 30-minute flight time. And then the analyzers, the millimeter wave MS-2760, and it's capable of going down into, I think, 7 kilohertz. So you have low frequency coverage as well. And 450 megahertz Yagi. This would be for two-way radio interference hunting. The kit clips on, which is nice because you're going to want to set it up separately away from the drone, and then finally, when you have it all set up, you can clip it onto the drone itself and power it from the drone. And I like that arrangement a lot to help me get everything set up on the bench, and then finally at the last minute clip it onto the drone and go do the measurements. You do have to have equipment on the ground. Of course, you have to control the drone. The center thing is the controller, so the pilot in command has to be doing that carefully, and hopefully there's a second person looking at the measurements on the ground. That will be done on a PC with I use Windows Remote Desktop to basically operate the equipment on the drone just as you would in front of you. So got a good downlink from the drone itself to make that work for as far away as you can legally fly the drone. You have to keep the drone in sight, of course. And last year, I've gotten software going to continually capture the measurements from the analyzer, the GPS location, and then also the compass to get the direction. So all those get tied into the file. They get updated once a second. And once you land, then you bring that file into your PC. And this is the software and the spreadsheet data that comes out of that file. And once you have a spreadsheet with all that data, then you can, you can use your own ability to move that into 3D plotting or back to Google Earth to do mapping of the measurement results. For interference hunting, you really just need the compass. So this would be an example display on the ground, a real-time analyzer display on the left, and then a compass display on the right. And of course, you're rotating the drone, going up to 400 foot, and slowly rotating the drone, watching the analyzer display, just as you would on the ground. And then once you've decided that that's the direction of the signal, you go move over to the compass display and log that, and then triangulate from that point, doing multiple locations. Of course, you have to do all this following FAA regulations. You should have the 107 license. You can't fly over people. You have to be able to see the drone. Total weight, 55 pounds, which is a lot. I don't get anywhere near that. The FAA has improved the process of getting airspace with the low altitude authorizations. And of course, the pilot is always responsible for any outcome. So no matter what happens, the pilot better know what's going on. And then the details of doing this, you always have to have landowner permission. You don't want us to be wandering around and violating people's privacy. Although I don't fly a camera, but people still think there's a camera on it. Approval of airspace. You have to, of course, follow FAA for weather, visibility. And these things are an attractive nuisance. So I find people walk over and want to talk to you while you're flying, and you just can't let that happen. You've got to keep them away as best you can. For this kind of work, flights are very simple, I think. Sometimes you may need to do a little mapping, but I typically fly up to altitude and just slowly rotate the drone and come back down. There are other scenarios where the drone's doing a lot of activity, but I don't think interference hunting or spectrum management is really going to get you into elaborate flying of the drone. So with that, I'll open it up for questions.
Great, Tom. Thanks. We're gonna. Do we have anyone who has any questions? We got a few. Hold tight. And anyone who's asking a question, if you can just introduce your who you are and go for it. So one here, one here.
Morning, it's Bob Weller with the National Association of Broadcasters. I had two questions. GPS is notoriously inaccurate on the Z-axis. So is that what you rely on for elevation determination or something else?
You're exactly right. I just ran into that last. Normal GPS is, of course, you have the add-on of real-time kinematics. So you have a GPS on the ground, and that can improve that tremendously. And then I'm seeing a change recently with the so-called pilot, the automatic pilots, the software and the mechanics that control the drones. They're adding more satellites. So it's not uncommon now to have equipment that looks at 25 satellites at once. That will improve the altitude as well. And of course, the altitude from the drone is done with a pressure sensor, not with GPS. So that's a little bit better. But you do have the ability to get better altitude out of the systems if you're willing to go to a little bit of extra effort.
Okay, great. And the second question is, it seemed like with these measurement systems, you're very weight constrained. You have to pay a lot of attention to the weight of the different components. Have you considered like flying a drone pair with omnidirectional antennas and use the TDOA, time difference of arrival, to determine the azimuth? It seems like that would eliminate a need for compass, directional antenna, spectrum analyzer. It would just potentially drop the weight quite a bit.
And I would think you would need a live link between the two drones to do that.
I agree. You'd need a ground connection so you can do the cross correlation. I'm not sure if you need, since the drones know where they are, or
Right.
the GPS. I'm not sure you'd need a link between them, but you'd certainly need ground links from both.
Okay. I haven't considered that. Of course, you need two separate pilots. It would be quite an adventure. I haven't studied that, so I don't know how to answer that question. Maybe a way to go, but I haven't studied it enough to give you a good answer.
Okay, somebody's patent opportunity.
Right.
We can present it next season. We had a okay.
Hi, yeah, this is Arup Muya from Idaho National Laboratories. I may have missed it, but have you connected your drone to a cellular network, or this is purely line of sight kind of connections for wireless?
Do you mean for control?
Both. I mean, what we have done is that we actually between the ground control station and so both are actually connected to a cellular network. The drone itself directly through the onboard computer and modem, and then of course the ground station controller can connect to the IP network that the server is and so forth. It's, for example, the mission planar control and things like that. So bottom line is that they actually have a path through the cellular network, so the drone can be on the East Coast theoretically. The ground control can be on the West Coast and things like that.
Well, certainly I've flown a cell phone, and you've got to be a little bit careful about half-watt transmissions near the drone itself.
Sure.
So you'll have to be careful with shielding.
Mm-hmm.
And I've heard so the beyond line of sight people are wanting to use a cellular network because, of course, they're going to be out of range of a normal drone controller.
Right.
So I know that work is being done. People have studied the BVE LOS people have done that work. A lot of issues, but I think it is progressing that way. I don't see an issue of, of course, you have to do the right engineering and make sure drone is safe and it isn't the drone has to be hardened enough to not be interfered with by the cellular transmissions from the device on the drone.
Yeah, no, good thoughts. Thank you.
Yep.
Okay. We have a front row here.
Hey, good morning. Mike Davis from the FCC. You'd mentioned that you'd flown it with a cellular phone payload.
Right.
So the question is that in our rules that 1.5 meters above ground level is the standard industry standard height for measuring your coverage. How do you fly the drone and then land it so that it has a 1.5 meter tripod, or do you hover at 1.5 meters, or do you do some kind of calculation to kind of convert the elevation back to the standard elevation for those kind of measurements?
So you're talking about doing cellular coverage at 1.5 meters, but with the drone?
Yes.
Okay. I haven't done that. I'm not sure that's a good use. I'd be very uncomfortable flying a drone that low. There would be very few places that you could do that. And I haven't done cellular coverage with the drone. I've done other kinds of coverage, but not cellular coverage. So I don't know. I'm not sure that's a good use of a drone to get the results at that low of an altitude.
Thank you.
Yeah. I'd be very uncomfortable flying at that low.
Okay. Tom, a couple other things. You'd mentioned the human terrain issue where you might be out flying a drone trying to you spend a lot of time planning. You got the drone up, you're doing all kinds of work controlling the spectrum analyzer and the drone and terrain, and then people walk up to you and like, oh, that's cool, what's going on? I assume you typically recommend in some situations where you're reasonably going to be running into people that you have at least your own little guard, your second.
I have cones, I have tape, keep away tape, and I've had people lift the tape up and walk under it to come see me.
Wow. So maybe you actually need another human on your.
You do. Yeah. You do. No, there's no question. You have to have policing, or the pilot in command is taking the risk there. It's exactly against the rules to have someone there who's not a part of the flight crew. So you're as soon as that happens, the pilot has to either land the drone and stop what's going on right now, or have another person drive the looky-loos away.
Yeah, and then you could lose the weather window or the battery level window or who knows what else with all that wasted time.
Yeah, I was flying last week, and you should check notice to airmen before you fly. And we did okay, let's check that. And the president was flying in, and all the airspace was shut down. So you better follow the rules. The reason the rules are there, and you don't want to have a drone in the air when there's been a NOTAM to no aircraft at all. That happens.
Yeah. Can you also speak to a couple things related to build out? One is, somebody who's trying to complete a build out, or a contractor is trying to help a licensee complete a build out. Are you using this presumably to help validate, build out or getting the contours right or something pre-build out site survey? Or can you talk a little bit about that?
What kind of system are you talking about?
If somebody's putting out, there's a variety of systems that have build out requirements, and typically a manager of a larger scale build out is going to want to be able to see their progress, both from an actual how many units or APs or whatever have been deployed, maybe pre-networking, so they can't really see them, but just actually see visually what's going on. Have you ever had that kind of or a third-party verification of a build out, which I guess regulators might be interested in? Have you seen any of those?
Well, certainly the people at the company Whisper that I buy the drone from, they've moved on to more photographic types of missions, but they were initially doing sighting for wireless internet service providers. So that's the origin of their name. And yeah, and they flew 5 gigahertz and 2.4 gigahertz antennas to assess the which link to attach to for a point for their WISP work.
Right. So I guess to expand on that, because sometimes the visual is not going to tell you what exact band somebody's operating in. A visual can identify maybe a make or model if you have enough acuity of the image, but you're not going to always see which sub channel it's operating on. Whereas if you can sniff it and photograph it and date stamp, time stamp, all that, that's proof of a build out.
Right. They flew an actual access point and attached to the system.
Nice. Okay. We got another question over the illustrious and magnificent Mark Gibson.
Hey, Mark.
Hey, Tom, this is a great presentation, but I had a sort of an FAA wonky question. So, with under Part 107, you're not allowed to fly in Class B, C, or D airspace, correct? Can you do that under waiver?
Yes, you can. If you use the LAANC low altitude authorization, if they approve it, you're good to go. Yeah.
How far in advance of a mission do you have to do that?
Well, it depends. It's capable, depending on which airport and how well they've outfitted that location.
Yeah,
it varies from instant. I mean, I'm serious. If you could get it right away to if it's more complicated, if you're doing like flying at night or trying to go above the 400 feet, if you want that kind of waiver, that's going to take longer. But the ordinary, if it really is safe, in many cases you get an instant thing. The LANC is a huge improvement in helping drone people get their work done.
Okay. Then another question, unrelated, in terms of battery, payload battery and other. So do you operate this on a separate battery, or is the battery you use this has to be part of the payload?
It depends. So my current payload takes 19 volts. The battery on the drone, on the Whisper drone, is 24 volts. So I regulate that down. Okay. So on that drone, I use the battery from the drone itself. But on the other drone I just have a separate battery. In fact, I'm using a battery from a drill, a light lithium battery from a drill to power the electronics. So whatever makes sense mechanically.
Okay, and then last question, and I'm not sure if this is allowed under Part 107, but can your mission be constructed to consider some level of autonomous operation? So, for example, if you need to fly a specific route, turn and do sort of like maybe you're flying a grid or set of circle, are you allowed to do that under Part 107? And can you?
Oh, absolutely, sure. And one of the reasons I happen to like the Whisper drone is that it has a center and a radius, so I can set a specific center and radius and do antenna pattern mapping. So no, that's absolutely allowed, and it's I use it all the time for antenna measurements.
Cool. Thanks.
Yeah.
Great. Going once, going twice. Tom, thank you. A lot of hard work and appreciate the field experience. Thank you so much.
Thanks, Joe.
So we'll be breaking for lunch. We'll be back in this room at 2:30 p.m. with Spectrum Management Guideline Developments, NSMA Working Group 3, helmed by NSMA board member David Meyer.